Okay, so here is the most important part of this lecture. All of those types of descriptive research that we just went over, survey, naturalistic observation, case study, those are what we call correlational research. It is not an experimentation. When we have our results from our question, does caffeine consumption improve first period grades? We can only say that there is a correlation between caffeine and first period grades. We cannot say that caffeine causes students to have higher first period grades. So what is correlational research? Correlational research is a technique based on naturally occurring relationships between two or more variables. So maybe we look at the studies, maybe we look at the grades, and we say, you know what, yes, people who drink 1 cup of coffee in the morning have higher grades than people who do not drink 1 cup of coffee. That is only a correlational data. That is only a correlational result, in that there is just a relationship between caffeine consumption and grades. We cannot say that caffeine causes students to have higher grades. Correlational research is important because it's used to make predictions. So for example, all of you at some point in time are going to take the SAT or the ACT. Your prospective colleges, the colleges that you apply to, are going to look at your SAT and ACT scores, and they're going to say, okay, based on their score, we can assume that they're going to do well or not so well in college. So SAT scores should, if it's a good test, correlate with good grades in college if you scored high on the SAT. So correlational research is only a relationship, and it's used to make predictions. Repeat this to yourself 5 times. Correlation does not equal causation. Correlation does not equal causation. Correlational research cannot be used to determine cause and effect. We cannot say caffeine causes better grades. We cannot say that the higher SAT scores causes higher grades in college. It is only a relationship. It is only correlation between the two variables. The two variables being caffeine, grades, only a relationship. Two variables being SAT scores, success at college, it's only a prediction. Make sure you know that correlational research does not mean that one thing causes another. Now, when we collect our data from correlational research, it's really good to make a scatter plot. A scatter plot, of course, you know from math and science, is a graph that comprises of 2 points generated by values of 2 variables. So on one axis, you're going to have one variable. On another axis, you're going to have another variable. Once you plot your data on the scatter plot, the slope of the points depicts the direction or depicts the strength of the relationship between 2 variables. So let's say for this scatter plot, it's a perfect positive correlation. Correlation, as you know from reading, is measured on a -1 to 1 scale. The more strong a relationship is, the higher the number is going to be, either in the positive or the negative direction. So on this scatter plot, you have 2 random variables that depicts a perfect positive correlation. Let's pretend that for this scatter plot, on this axis we have SAT scores, and on this axis we have success at college. Because we know that SAT, for the most part, is a good prediction of success at college, we would say that it had a perfect positive correlation. Now, that's not true in real life, but what this scatter plot is showing is that as one variable goes up, the other variable goes up. As one goes up, the other goes up. That's a perfect positive correlation. Scatter plots, of course, can be negative as well. So a positive scatter plot means the variables either increase together or they decrease together. A negative scatter plot means as one variable increases, the other decreases. And if there is no correlation at all between our 2 variables, the number is going to hover around 0. So look at this graph right here. these two variables, auto quality and auto body color, we're talking about cars, they have no relationship with one another. If we were trying to figure out if certain color cars were better in quality, we would find that that is not true, that there's no correlation between those two variables at all. And when we plotted our scatter plots, it would look something like this, all over the place. Whereas, again, going back to a positive relationship with two variables, the auto accidents, as that goes up, as you have more and more automobile accidents, your auto insurance cost is going to go up. And we know that to be true. If you've ever gotten in an accident, you know your insurance goes up because you're having to file a claim. Now, here is a negative relationship between two variables. This is saying as auto mileage goes up, so the more miles you have on your car, auto value increases. We know that to be true, untrue. The more miles you have on your car, the less your car is worth. And so a negative correlation is going to look like that. It is very important that you know that positive correlations mean that the variables increase or decrease together, whereas a negative variable means as one increases, the other decreases. Don't think that just because the correlation coefficient, that number, don't think that just because it has a negative in front of it means that those variables are not related at all. That is very important for you to understand. You're going to be doing some practice in class with plotting these correlational scatter plots. The scatter plot on the left, again, shows a perfect negative correlation, and the scatter plot on the right shows no relationship at all. Remember that a correlation coefficient is measured between -1 and 1. The closer the correlation coefficient is to 1 means the stronger those two variables are. Either they go up together, they go down together, or as one goes up, the other goes down. Whereas two variables that have no correlation, they're going to hover closer to that 0 number. Now, as far as correlation goes, when surveys and naturalistic observations reveal that one trait or a behavior accompanies another, we say that those two correlate. So once we find out that yes, in fact, caffeine consumption does correlate with higher grades, we can say that that's a positive correlation. And again, the correlation coefficient is a statistical measure. It's that number of a relationship between two variables. It's going to be measured from -1 to 1. So let's take another example of something that might be a good example of a correlational research. We want to study depression, and we think as researchers that depression correlates with having low self-esteem. So people who are depressed have low self-esteem, and people who have low self-esteem are going to be more susceptible to depression. We want to do the research because we assume that these two variables are related. So what we do is we give individuals a self-esteem test. It's probably going to be a survey. It's going to ask them questions about their self-esteem. That's our first variable. The second variable that we're studying is the length of a depressive episode that they're having. So once we get their scores on the self-esteem test, we can ask them questions about how long they have been in a depressed mood and go from there. We've plotted our variables on a scatter plot, and we'll say that this axis says is self-esteem, and the second axis is depressive episodes. So what this is saying is that the higher your self-esteem, the less likely it is that you have had a long bout of depression. Again, we'll go the other way. The more depressed you are, the less self-esteem you have. So would this be a positive or negative correlation? If you said negative, you would be absolutely correct. The higher your self-esteem goes, it increases, your level of depression decreases. That should make perfect sense to you. Now, you could do it or look at it this way. Low self-esteem could cause depression, or depression could cause low self-esteem, or you could have some completely random biological predisposition in your genetic code that could cause both low self-esteem and depression. But again, because this is a correlational research, we cannot say that low self-esteem causes depression or that depression causes low self-esteem. We only know them to be negatively correlated with one another. Positive, negative, no correlation, academic success in school and self-esteem. What do you think? Would this be a positive correlation, negative correlation, or no correlation at all? So what this is saying is that the more successful you are academically, the higher your self-esteem, or the lower your self-esteem. I want you to contemplate this, and I'm going to ask that you respond to me via message or email and tell me your hypothesis for this and whether or not you think it's positive, negative, or no correlation, and why. All right, guys, we'll get to experimental research tomorrow. Please email me with any questions.